Welcome to solverfy.
All right, in this question, we're looking at the difference between propanol and ethyl methyl ether, both of which have 3 carbons. So propanol, get my pointer up here. Propanol is going to have an OH group at the end. That's what the "ol" means. It's a alcohol. So propanol here is going to look like carbon with 3 hydrogens coming off, another carbon with 2 hydrogens coming off, another carbon with 2 hydrogens coming off because prop means 3 carbons, and then the "ol" part is our OH group here. The ethyl methyl ether is going to look like there's a carbon here with 3 hydrogens coming off, a carbon with 2 hydrogens coming off, an oxygen in the middle of 2 carbons here, so there's the 3rd carbon. Again, this one has 3 hydrogens coming off. So that's the basic structure of those guys. So in part A, the question asks us which molecule, if any, can engage in hydrogen bonding. So hydrogen bonding is a type of intermolecular force between molecules, and it's a force between a hydrogen and that's bonded to, so the hydrogen has to be bonded to an F, O, or N, so it's between that and the F, O, or N. So if we look here on propanol, I have a hydrogen bonded to an O. So propanol can engage in hydrogen bonding because there is a hydrogen bonded to an F, O, or N. Here, all my hydrogens are bonded to carbons. There is no hydrogen bonded to this oxygen. Therefore, ethyl methyl ether cannot engage in hydrogen bonding. In question B, it says, which molecule would you expect to have the larger dipole moment? Well, both molecules have oxygen bonded to different elements that have lower electronegativities. Therefore, both, and neither of them are symmetric molecules. Therefore, both molecules are going to be polar. But this OH bond at the end of this molecule is really going to attract electrons towards this end of the molecule and away from this end, making propanol have a fairly significant dipole moment, where here you have carbons on each end and oxygen in the middle. It will still be polar, but you're not pulling the electrons in any one specific side nearly as much as you are in propanol. So both polar molecules, however, propanol will have, because this OH bond will have the higher dipole moment, larger dipole moment. So that is also propanol for that one and this one. The last question tells us that one of these molecules has a normal boiling point of 97, the boiling points of 97.2 degrees Celsius, and the other one has a normal boiling point of 10.8 degrees Celsius. And they ask us to identify which one is which. So boiling point is based on intermolecular forces. The stronger the intermolecular force between the molecule, the more energy you need to break those intermolecular forces. More energy, more kinetic energy. More kinetic energy means higher temperature. So the stronger the intermolecular forces between the molecules, the higher the boiling point. So we know, we already said that propanol can hydrogen bond. That's really your strongest intermolecular force between molecules. It also has dipole-dipole because it is a polar molecule, but really the hydrogen bonding is a special type of dipole-dipole, and then it's going to have London dispersion forces. Ethyl methyl ether is going to have dipole-dipole because it is a polar molecule, so it will have dipole interactions, and it will also have London dispersion forces. But here, this hydrogen bonding is stronger than dipole-dipole and definitely stronger than London dispersion. So since it has the strongest intermolecular forces, the propanol will have the largest or the highest boiling point. So this 97.2 is going to belong to the propanol, where the lower boiling point is going to belong to the ethyl methyl ether.